Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on inverse functions, which is part 3 of the functions series. You should have already checked out the first video on normal functions, which is a really quick and easy video to go through. Then we had composite functions. Now you don't necessarily need this video to understand inverse functions, but it does kind of come before in the series anyway. And then there's one more afterwards, which will put all of the first 3 videos into practice together. The other thing to note is that this is a higher tier topic only, the whole of this, so if you are foundation tier, you can ignore this video as well. So let's get straight into it. So inverse functions are represented by this type of notation here. You can see the f to the power of a -1, a -1. Now inverse, that kind of happens as a -1 in other contexts as well. As you might know with using trigonometry, you'll see on your calculator, not only do you have sin, cos and tan as buttons, but just above it you'll have sin to the -1, cos to the -1, and tan to the -1. That's the inverse of sin, cos and tan, okay? So you might have seen this before, but what are we referring to by an inverse function? Well, basically we're literally going to inverse it, okay? We're going to take the original function, as you can see here, 3x minus 1, and we're going to inverse it. I kind of imagine it as, I don't know why I get this mental image that we're kind of turning it inside out. We're like reversing it. We're kind of undoing it. However you want to remember it, doesn't matter. But I'll show you what we're going to do. So, given that f of x, so the original function, is equal to 3x minus 1, find the inverse function. So what we're going to do is we're effectively going to use the process of changing the subject of the formula. You can keep using f of x if you like. You might prefer to just use another letter like y. So I'm just going to show you what I would do. I'd say let f of x equal y, just because it's a simpler thing to write down than f of x. That's the only reason, okay? You don't have to do that. So I've now got y equals 3x minus 1. And what we need to do is change the subject. I want to make the x the subject. So what we would have to do in this case is we'd have to add the 1, wouldn't we, to move it across. So we'd have y plus 1 equals 3x. And then we'd have to divide by 3, wouldn't we, to get just x on its own as the subject. So we would end up with y plus 1 over 3 equals x. This is what I mean by we've kind of turned it inside out. We've like literally reversed it. Inversed it, haven't we? Do you see how before it was -1, now it's +1? Before it was multiplied by 3, now it's divided by 3. So it's literally the opposite, isn't it? Now obviously we don't want the y actually though, do we? We don't want y related. So all you need to do if you've done that, if you swapped out the f of x for y, is you need to replace y with x, because everything is still in terms of x, isn't it? So we've got x plus 1 over 3, and obviously where it says the x here, that's just the inverse function, isn't it? So at the end I've just swapped them back, effectively. I've just kind of used the y, just as a simpler way of writing the f of x. I don't really want to write f of x every time, but you can do if you want. The main point is you just need to basically undo or reverse everything that's happening originally and get it so that it's basically the opposite, isn't it? It is the inverse of the original function. So let's try this again. Given that f of x is equal to x plus 2 over 5, find f of minus 1x, which is the inverse function. Find the inverse function. So I'm just going to start off again with let f of x equal y, just because I think it looks a little bit easier than using f of x. So I actually have y equals x plus 2 over 5. Now I just need to change the subject to make x the subject. So I have to times by 5 on both sides to move the 5 across, isn't it? So I get 5y equals x plus 2. And then I just need to minus the 2 to get x on its own. And then I have 5y minus 2 equals x. So I've changed the subject. And as we've just said, you can see it's the opposite, isn't it? We've inversed it. Before we had divide by 5, now we have times by 5. Before we had plus 2, now we have minus 2. It's literally the inverse, isn't it? And all you need to do at the end is remember to swap everything back. So we don't actually want y. So put the x back where the y currently is, and then just put it equal to the inverse function notation. So the inverse function is 5x minus 2. Okay, we are literally just reversing it, aren't we? We're just doing the opposite thing. We're changing the subject. Okay, as you can see here, and we saw with composite functions, it might not always be f of x, it might be g of x. It just depends, so don't be thrown if they use a different letter. Still the same thing. So, given that g of x is equal to 2x over 3 minus 4, find the inverse function of g. So, I'm going to replace g of x with y. As I said, that is optional. I just think it looks a bit easier. So I've got y equals 2x over 3 minus 4 separately, isn't it? So I need to make x the subject. This time I've got 3 steps, haven't I? Because I've got 3 numbers I need to move away from the x. I'm actually going to add the 4 first, because it's just on its own, isn't it? It's an easy number to move across. So I've got y plus 4 equals 2x over 3. Now I'm going to multiply by 3 to get rid of that fraction. I'm going to move this up to the top so you can see it better. Bring it over here. So I've got 3 times that. Now you can just do 3 times y and 3 times 4, or you can write it in brackets if you like. I'm just going to write it like this. Remember though, it's not just 3 times y plus 4, okay? It is the whole thing, 3 times y and 3 times 4, if you are going to expand it. That gives us 2x. Now I just need to divide by 2 on both sides. So I'm just going to leave it as a fraction, literally. So I've got 3 times y plus 4 over 2 equals x. So you can see again, we've literally inversed it, haven't we? Now we're dividing by 2 instead of timesing. We're now timesing by 3 instead of dividing. And we're adding 4 instead of subtracting it. Last bit though, remember, we've worked out the inverse function, but obviously we have to write it in terms of the inverse function, don't we? So in this case, we've got the inverse function of g equals, and then just swap the y with the x again. So we've got 3 times x plus 4 all over 2. There's your inverse function of g. So given that g of x is equal to x squared plus 7, find the inverse function of g. So we've got let g of x equal y. So I'm going to put y equals x squared plus 7. And now I just need to inverse it so I can get x as the subject. So I'm going to subtract 7 first to move that away. So y minus 7 equals x squared. And then the opposite of squaring is square rooting. So I'm literally just going to put the square root on both sides. So square root y minus 7, obviously we don't actually know what that is. We can't work it out, right? So just leave it with the symbol. And obviously then the square root of x squared we know is just x. Okay, so we've inversed it. However, as always, we have to swap the letters back. So the inverse function of g equals, and just where it says y, we're going to replace it with x. So square root of x minus 7. And you can see that's literally the opposite, isn't it? We had plus 7, now minus 7. We had x squared, now it's all square rooted. So if you're happy with changing the subject of an equation, this is just basically that. It's really not anything new. Okay, let's try one more before we go on to the next part of inverse functions. So pause the video, try this one yourself, see what you get. So I've gone back to f of x now. So let f of x equal y. Y equals x minus 3 squared minus 1. So to get x as a subject, I'm going to add 1 first, because that's just on the outside, isn't it? Y plus 1 is equal to x minus 3 squared. Now I'm not going to expand this, okay? I'm literally just going to square root it. Just want to open up those brackets. So square root both sides, and again we can just write it as square root of y plus 1 equals x minus 3. That's now opened up. And the last thing we need to do is add the 3, isn't it, to both sides. Let's bring it up here. So we've got square root of y plus 1, and then separately on the outside, plus 3 equals x. And finally just swap it back. So we've got f minus 1x equals, where it says y, we're going to put x plus 1, square root of x plus 1, and then separately plus 3. It's literally that. We're just literally changing the subject, basically. Okay, so as you will have seen with the other two videos, not only do we need to know the process of finding inverse functions, we also need to know what to do when they give us an actual value for x. So if you remember with the previous videos, when you have a number in the brackets, that's just replacing the x, isn't it? Saying when x is 3, find the value of the inverse function of x. So when x is 3, what is the actual value? Now I know with composite functions, we said you've got two options. You can either work out the composite function, then substitute the number in at the end. Or we said you can substitute the number into the first function and then substitute that value into the second function. With this one though, we have to find the inverse function first, then put the 3 in, otherwise it won't work. In this case, the 3, right? Then put the value in, so you have to do it that way around. So step 1 is to do what is the inverse function of x in general. Okay, then step 2 is to substitute the number in. Okay, so that's what we're going to have to do. So step 1, as we said, we had let y equal f of x. So y equals 8x minus 13. When I want to find the inverse function, I'm just going to do this a bit more quickly now. I need to add the 13, don't I? So y plus 13 equals 8x, and then I need to divide by 8. So I've got y plus 13 over 8 equals x. And obviously I therefore need to write it in terms of the inverse function. So the inverse function of x, we're going to swap the y with the x, is x plus 13 over 8. And then as we said, let's do step 2 over here. Now I can substitute in the 3. So where x is, I'm going to put 3. So I've got 3 plus 13 over 8. Right? And you just, if it's a calculator test, just put that in your calculator. But if not, you can work it out. So 3 plus 13 is 16 over 8. Obviously, that's then 2, isn't it? The reason why I'm not going to substitute in the 3 first and then try and invert it, right, is because let's say if I did 8 times by 3 minus 13, well, that's 24 minus 13, which is 11. And then how do I invert, how do I inverse that to get 2? Do you see what I mean? You can't really make that link. So with composite functions, you can substitute in first and then go from there. You've got the option of doing either. This one, you do have to work out the inverse function as an expression, so with the x, then substitute in the number afterwards. Okay, you have to do it that way around. Okay, pause the video, try something out yourself. Remember, work out the inverse function first, then substitute in the value. So we've got, given that f of x is equal to minus 4 times x minus 2, find the inverse function when x is 2. So, as I said, for step 1, we need to find the inverse function of x. So let f of x equal y. We're just going to replace that so it's easier, isn't it, to invert, literally. I'm going to first divide by minus 4. So I've got y over minus 4 equals, and then this opens up, doesn't it? Then I just need to add the 2. So y over minus 4 plus 2 equals x. And as we said, we have to then rewrite it, don't we? So where the y is, that's where the x goes. So x over minus 4 plus 2. Okay, then step 2, I'm now going to substitute in the 2 where I have an x. So obviously here, 2 over minus 4 plus 2. Well, that would simplify to minus a half, wouldn't it? Plus 2, which would give me 1.5, or basically 3 over 2 as a fraction. Okay, so do the inverse function first, then work out the value afterwards. Okay, again, pause the video, try this one out yourself. We've also got g of x now, but as I said, it just swaps depending on the question. It doesn't make any difference if it's f of x or g of x. So given that g of x is equal to 9x minus 1 over 11, find the inverse function of g when x is minus 5. So we're just repeating ourselves now, aren't we? We're going to find the inverse function of g first. So let g of x equal y. So we've got y equals 9x minus 1 over 11. Now this one has 3 steps, doesn't it? Because we've got 3 numbers we need to move around. So I'm just going to do it a bit quicker. I know I need to times by 11, so I've got 11y. I then know I need to add 1, and then I'd have to divide by 9, wouldn't I? So you can kind of do it in one step if you can see it clearly, but make sure you haven't made any mistakes, okay? Because doing multiple steps in one with algebra particularly can easily go wrong, but that's what we get. And as we said before, we have to rewrite it, don't we? So instead of y, I want to put x. So 11x plus 1 over 9, that's literally the inverse. Then I'm going to substitute in this case, minus 5. So where it says x, I've actually got minus 5. So 11 times minus 5 plus 1 over 9. So 11 times minus 5 would be minus 55, wouldn't it? Plus 1 over 9. So we've got minus 54 over 9, which is minus 6. There's your answer, minus 6. Okay, so that's how we would work with inverse functions when we are given a value of x as well. It's just like an extra step at the end. Now, the final two examples we have, similar again to what you will have seen when we did composite functions, is what do we do when actually we're not told what x is, but we are told to solve an equation. So we're saying we don't know what x is, but the inverse function is equal to a half. So we can use that information to go backwards and find out what x is. So given that f of x is equal to 3 minus 10x, solve, the inverse function is equal to a half. So again, first we would work out, well, what is the inverse function, right? So let f of x equal y. So where we have f of x, I'm writing y instead. So y equals 3 minus 10x. Okay, if we want x to be the subject, we need to subtract 3 and then divide, not just by 10, but by minus 10, isn't it? And we would rewrite it where the y is actually x. So x minus 3 over minus 10. So that's the inverse function. Then we can actually write it as an equation and solve it. So we know that x minus 3 over minus 10 is equal to a half. Now we've just got an equation, haven't we? It's not even functions anymore. It's just an equation that we need to solve. It's a linear equation. It's just x, isn't it? It's not x squared or anything. So the way we're going to solve that is we need to get x on its own. So I'm going to cross multiply. What that means is I'm just going to multiply by both of the denominators. Okay, so multiply by 2 would bring it to the left-hand side, wouldn't it? So I'd have 2 times x minus 3. And at the same time, multiplying by minus 10. 1 times minus 10 is minus 10. So I've just cancelled out both denominators in one step. Now, either you can expand the brackets or I'm just going to divide by 2, so I don't have to expand. So both sides divided by 2. Minus 10 divided by 2 is minus 5, isn't it? Then I just need to add 3. Okay, so minus 5 plus 3 is minus 2. There you go. X is minus 2. So we've solved this equation. We've actually found out what x is. And as I said, with composite functions, it's kind of the opposite of the few questions we were just doing. Those few questions, we were given what x was. We had to find out the end value. Now we've been given the end value, and we had to work back to find out what x was. Effectively, it's like the minus 2 is here, isn't it, in the brackets? Okay, so we have one more example of this. Hopefully, if you feel confident, pause the video, try this one out. Otherwise, we will go through it. Given that g of x is equal to the square root of x plus 8, I think that's definitely just the square root of x on its own. Okay, it's not including the 8. Over 2. Solve the inverse function of g being equal to 16. So as we said, first, what actually is the inverse function of g? So let g of x equal y. And we need to invert it. So we've got y equals the square root of x plus 8 over 2. So I obviously need to times by 2 first. I've got 2y minus 8, and then we can square it. So squaring this, I'm just going to put it in brackets and squared. I'm not going to expand it. There's not really much point, to be honest. And then we just need to rewrite it. So where it says y, I'm going to put x. I've got 2x minus 8 squared. Step 2 is then actually just solving the equation, isn't it? So I've got 2x minus 8 squared equals 16. At this point, actually we've got two options here, haven't we? Because 16 is a square number. You can either expand this, because this is technically double brackets, isn't it? Expand it, rearrange it, you're going to get a quadratic. Then factorize it again, but actually we can just square root both sides. The only thing you do have to remember though is because we were going to get a quadratic, we are going to get two values for x, as you will have seen in the previous video as well. So if I'm going to square root both sides, I've got 2x minus 8. However, obviously square root of 16, it is 4, but it could also be minus 4, couldn't it? Because we know if we have minus 4 and we square it, that also makes 16. Right? So when we square root 16, we don't know if the original was 4 or minus 4. So if you are going to square root it and do it that way, just make sure you are happy with the fact that you have to remember there is also a negative possibility. We should have two solutions. Okay, that's fine. Then we can obviously just add 8. So we've got 8 plus or minus 4, and then divide by 2. Now that obviously looks complicated, but you can actually just work that out. Like the two options are obviously 8 plus 4, which is 12 over 2. So that gives you 6. That's the one for the plus. Or if it's minus, you've got 8 minus 4. Obviously that's 4 over 2 is 2. So your solutions are, let's actually rewrite that, shall we? X is equal to 6 or x is equal to 2. You've got two solutions. As I said, that's a bit faster than if you were to expand it and factorize it, but it would work to expand and factorize as well. So that's your final answer, but let me go through, I'll show you the expansion one just in case you had gone through that route. Okay, so I'm going to write over here a little bit more. Obviously, 2x minus 8 squared, that's like double brackets, isn't it? 2x minus 8 times 2x minus 8. I'm not going to write out the double brackets. I don't think I have enough space, but we're going to expand the double brackets. So we should get 2x times 2x is obviously 4x squared. 2x times minus 8 would be minus 16x, but you'd then have two of those, wouldn't you? So I'm just going to put it all in one, minus 32x. And finally, minus 8 times minus 8 is plus 64, equals 16. Okay. This is where you can see obviously we have got a quadratic, and if you remember, solving quadratics is different to linear equations. We can't isolate the x, so what we need to do is get everything on one side, all of the terms on one side of the equation, a 0 on the other side, and then factorize. So I'm going to move the 16. So I need to subtract 16, don't I? So I've got 64 minus 16, which is 48, equals 0. Okay, perfect. Before I factorize though, you can factorize this, but before, ideally I don't really want something in front of the x squared. It'd be easier to factorize if it's just 1x squared, wouldn't it? So double check, is there any common factor between all three of these terms? And in this case, yes, 4. We can divide everything by 4, can't we? It's the same as if you have a fraction. If you have a common factor in the top and the bottom, or the numerator and the denominator, you can divide by that, can't you? You can simplify the fraction. It's still the same fraction, isn't it? I've just simplified it. So same here, it's still the same quadratic. I'm just going to make my life easier by simplifying it. So divide everything by 4. So we've got x squared minus 8x plus 12 equals 0. Now this will be easier to put into brackets because I'm not worried about combinations of 2x and 2x or 4x and 1x or whatever else. So it's obviously x and x. Now we're multiplying to make a positive, but when we add them, they're negative. So we're going to need two negatives, obviously still equals 0. Factors of 12 that add up to 8. Well, 2 and 6 would work, wouldn't it? And then from there you'd solve and go, I'm not going to write it out, but you remember how we said, obviously if you're multiplying two brackets together, you've got 0 as your answer. The only way to multiply two things together and get 0 is that one of those two things also has to be 0, if not maybe both of them. We don't know which of these brackets equals 0. We know that one of them has to, though. As I said, if not maybe both of them. So let's say if the first bracket equals 0, then x would be 2. Or if the second bracket equals 0, then x would be 6. So you can see we've got the same exact answer that we had when we did the first version. That one's a bit easier because I could square root 16. If this number here isn't a square number, you would have to then expand it all out and everything. But the fact that 16 obviously was a square number, it was easy to square root both sides. So you've got those two options, whichever you feel more confident with. Either way, your answers are x is 2 and x is 6. Okay, so thanks for watching that video on inverse functions. We've basically now covered everything about functions. The main two bits, as I said, are composite functions and inverse functions. So thanks for watching this video, and leave any questions you might have down below in the comments.